All right, today's topic is frequency and wavelength. All right, so we've talked about we're going to be using the transverse wave, which is the wave diagram that we just got quizzed on right now that has the crest, the troughs, and the amplitude and all that stuff. And so what we want to do is we're going to be drawing, I'm going to draw two waves side by side so that we can kind of understand how wavelength and frequency relate to one another, okay? Now, there is a diagram that is on your reference sheet that we will be using, let's see, sometime next week, on Monday of next week. All right, but to understand that diagram, it requires you to remember today's main lesson. So again, today's lesson is kind of short, especially since we're on our release. That's why I'm focusing just on frequency and wavelength. So what I'm going to do first is we need to first understand what is frequency, okay? So now there's the definition that I give you in the vocabulary sheet, but then there's the definition that I need you to understand so that you can apply the skill that we're going to try to learn today. So frequency is basically this. I'm going to give you two definitions. First is going to be is how often a pattern is repeated in a given amount of time. Okay, so in a stretch of time, whether it be like 1 second, 5 seconds, 2 minutes, whatever it is, in a stretch of time, how often does the pattern repeat itself? That's what a frequency is. How often? Because again, when you say frequency, like when you talk about those commercials that talk about people who have like active bladders, you know, it talks about the frequency that they go to the bathroom. How often do they go to the bathroom? Okay? So that's what frequency means, is pertaining to how often a pattern is repeated in a given time. However, in relationship to our diagram, the pattern that we see in our diagram is that we see a crest and a trough, and then what happens is I repeat the crest and the trough. That's what you saw in your diagram yesterday. So if you're looking at the diagram that you drew yesterday, you should see that there is a crest, a trough, followed by a crest and another trough, and that's the pattern that's going to repeat over and over and over again. So for our sake, what we want to know is, in the case of frequency, frequency is how many crests in a given space. That space will usually represent the given amount of time. Okay? So what we are going to focus on specifically is crests. Okay? Now, frequency is something that we can measure, and it's measured in hertz. Okay? So frequency is something that we can measure, so that means there will be a formula that comes into play. That formula we will learn tomorrow. All right? But in that case, if we're measuring frequency, frequency is measured in hertz. All right. If in relation to computers, you may have heard things like megahertz or gigahertz. Well, again, that's pertaining to frequency. Now, what I need to do here, though, is this. So after this point, what I want to do is I want to erase the board so I can draw my two diagrams and make sure we can write down what we need to write down underneath it. Because now it's more about you being able to look at a diagram, see what you're supposed to see, and then get the answer to the frequency question based on the frequency and the wavelength. All right, so with that in mind, can I erase, or is somebody still writing?
Is that a 2 or anything?
That's a Z, because it's H-E-R-T-Z, so capital H, lowercase z. All right, are we good? Shanti, if I'm not, you better tell me no, or I'm going to erase, and you're going to be wondering what you had up there. Are you still writing? All right, what line are you on? Last one? All right. Okay. We're going to draw two waves side by side, okay? And I want you to have them side by side in your notes as well. So make sure that you draw those waves. All right, now, I think we're good? All right. So to make sure we understand frequency, we're going to draw two waves. I'm just going to call them wave number 1 and wave number 2. So wave number 1, okay, and I'm going to draw wave number 1 like this. Okay, that's the wave, kind of like the ones that we saw yesterday. And then right next to it, I'm going to draw wave number 2. So again, make sure you don't draw them as large as you did yesterday. Otherwise, you'll only be able to fit one. I want them side by side. I want you to be able to look over here, look over there, and see exactly what you're supposed to see. Not top to bottom, left to right. Wave number 2. Now, if we look at both waves, I tried to make both waves with the same amplitude. Okay, remember, what did we say, Eric, what did we say an amplitude was on our diagram? The height. Okay, so I try to make sure from our resting point to the top of the wave. Again, what was the top of the wave, Barney, called? Crest. Okay, I try to make sure that the height from the resting point to the crest was the same over here as it is over there. So that way we won't get confused of the issue of frequency dealing with height, because it's not about height, it's about the crest. Okay, and I know the crest is the high point of the wave, but we're not talking about to see how high a wave is. So in this case, they both have the same height. So height has nothing to do with frequency. Okay, now when we look at this right here, here's what I want us to look at here, all right? Because this is the big idea. So we're going to go underneath this. We're going to write down the wavelength. Okay, we're going to write down the wavelength. And if I have a ruler that is hopefully good, perfect. All right, we're going to measure the wavelength here. Okay, we're going to measure the wavelength. Remember, the wavelength is the distance from one crest to the other crest. Or we could say from one trough to another trough. Remember, the definition said it's from two similar points on back-to-back waves, or back-to-back, waves. All right. So we're going to say right here is a crest right here. Here's going to be the other crest right here, and I'm going to measure that distance using centimeters. All right. And so when I get that, I get 21 centimeters. All right. So the wavelength is 21 centimeters. We've measured that. All right. That's important because I don't want this to be. Men have this problem of saying, hey, I'll just eyeball it and then be able to know what I'm talking about. Well, we're not eyeballing it. Let's measure it. That's 21 centimeters. So again, when we get to an answer, all right, over here, I'm going to do the same thing. I want to get to a wavelength for this particular guy. And again, for the wavelength, I'm going to go from crest to crest. What do you notice about the gap between these two crests and the gap between these two crests? What do you notice about the crest gap between in wave 2?
Wave 2 have a shorter crest.
Well, the gap is smaller, right? And so what we're going to do is we're going to justify that by measuring that gap. So when I measure that gap, I'm going to get 7 centimeters. Okay? So if I asked you the question, so here's one of the most easy questions that I could ask you, and that would be this. Coburn, wave 1, wave 2, which one has a bigger wavelength? Wave 1. Okay? Easy question, Kevin. Wave 1, wave 2, which one has a smaller wavelength?
2.
Wave 2, right? So that's easy to understand, correct? All right, and that's also easy because you can tell by the gaps. Okay, so when I'm talking about wavelength, I'm looking at gaps. But the other thing that I'm going to look at is frequency. And when I look at frequency, I also will look at gaps. But I'm not getting the same response. Okay, so here's what we're looking at here. In the case of wavelength, we're going to see at a wavelength of 21 centimeters, is going to get us a frequency. Now, frequency is this. It's how often the pattern repeats. That's what we said, correct? And I said that the pattern is crest, trough. So in this wave right here, how many crest, trough patterns do we see? All right, I knew you were going to say that, so that's why I want to make sure. I'm going to do something right now that I want you to see. What's not, you don't need to outline this in your notes. I just want you to analyze this. This right there, that I just outlined in red, that is one cycle. Okay? Like that's the pattern. Crest trough, that's pattern 1. Get what I'm saying? Like that one crest, one trough equals one pattern. Are we good? So how many times does the pattern repeat? 3. 1, like 1, 2, crest trough, 3. Does everybody see that? Yeah. But now remember my definition, I said it's the number of crests, right? So so that you don't have to always go tracing, you could just go 1, 2, 3, right? Well, the easiest way for you to do it would just be like this. And this is one that you want to pay attention to. So if you're going to miss everything else, don't miss this. When I want to know the frequency, I'm going to do this. 1, 2, 3 crests. Okay? How many crests? 3. 1, 2, 3 troughs. How many troughs? 3. Do those numbers match up? Yes. So therefore my frequency is 3 hertz. Okay? That's how that works. All right, now I'm going to show you a weirdo after we do these two. But right now, what I'm wanting you to see is the pattern repeated once, twice, 3 times. That's one way you could do it. Or we could just say 1, 2, 3. 1, 2, 3, 3 and 3. So 3 must be the number that goes in that spot. All right, are we good right there? Yes? No? Because this is the only skill for today. I mean, if you don't get this skill, then you're going to be kind of ruined for tomorrow and for the rest of the week. All right? So let's go over here to wave number 2. I think I saw Jayla over there go ahead and trying to count the number of crests, trying to figure out the frequency, right? So the question again is this. You could either outline, and I know some of you, it's probably hard to see these things, right? That's why, again, you might want to just look at your paper. Hopefully it's close enough. Again, I could outline how many times does the pattern repeat, once, twice, 3 times, right? But then again, the easiest way for me to do it is just to simply go there and count the number of crests. So I go over here and I count 1, 2, 3, 4, 5, 6, 7. How many crests? 7. Let me go to the troughs. 1, 2, 3, 4, 5, 6, 7. Do they match? So what's the magic number? 7. Okay. Now let me go ahead and just, because this happens to be coincidence. All right. It's just a coincidence that those numbers match up right there. That the wavelength and the frequency, they don't always match up. Okay. That's just coincidence. That's just lucky. Okay. It's just lucky. So don't think it's going to be like, well, doesn't the wavelength and the frequency got to match? No, they do not. All right. That's just sheer luck that they did right there. But that's the 7. That's your frequency. Okay. So now, here's what I need us to see, because this is the big idea that connects wave number 1 and wave number 2 together. All right. And that is this. I'm going to go back to my original question. I think it was to Eric. No, I think it was Coburn. Coburn, which wave has a bigger wavelength? 1. Okay. Kevin, which wave has a bigger frequency? 2. Everybody see that there now? So notice, the wave with the bigger wavelength is not the wave with the bigger frequency. It's the other one. Okay? That's, again, that word that we've been learning all semester. That there is your inverse proportion, meaning when the wavelength gets bigger, your frequency gets smaller. All right? And that's what we want to write down here. So we want to write down here is this. If wavelength increases, then frequency decreases. Okay? They are oppositely related. Because remember, if a wavelength is the space between you and the person next to you, well, if that space increases, can we fit more people in the elevator or less people in the elevator?
More people.
You sure about that?
Yes.
You fit less. If the distance between you and the person next to you, like right now, if I got a person, they're like 3 inches away from me, right? That means we're kind of close together. It means we can fit more people. But what if it's that person's now is 3 feet away from me? If everybody's 3 feet away from the other person next to him, you're not going to have as many people in the elevator, right? That's the same idea here with wavelength. If I got more space between my crests, then I can fit less crest in that space. All right? That's why this one here, shorter wavelength, higher frequency. Bigger wavelength, lower frequency. So the opposite is true, right? The opposite is true. If wavelength decreases, then frequency increases. Did we get that? That's important. Okay? So that's the one thing I want to make sure we get about wave 1, wave 2. All right, and this one right here. Are we good right now? All right, because now let me show you the weirdo. So now we understand the big idea. Let's go ahead and write this down. This is the big idea. Okay? That's the big idea. That you understand that when wavelength increases, frequency decreases. Or that when wavelength decreases, frequency increases. That's the big idea. That they are connected. But you got to know how they're connected. So now I'm going to draw another wave. Okay? Can I erase? Tell me no. I hear no no's. So I erase. All right. I figured y'all would be happier with early release, man. Y'all still just as deathly silent. All right. We're going to draw. This is going to be wave number 3. Now, I don't care where you put this one. This is just wave number 3, so you know that it's not with the other 2 waves. Okay? All right, so let's go right here. We're going to go 1, 2, 3. There we go. All right, there's our wave. Okay, now just to get into the habit, I'm going to put the same thing down. I'm going to put wavelength equals, and then I'm going to put frequency equals. And I'm going to put a little asterisk over here next to frequency, because that's the point that I'm emphasizing in this particular diagram. All right, where is my ruler? There is my ruler. All right, wavelength is 20 centimeters. So I almost drew it exactly the same width as the other one, off by 1 centimeter. However, I didn't care. I wasn't going for that. All right. Frequency, how often it repeats, okay? So let me go ahead and let you get caught up, because I don't want you to miss this one, because if anything is going to screw you up, it's going to be this one here. All right, speaking of, tomorrow, you notice in today's quiz, I gave you a wave diagram, correct? Mm-hmm. Well, tomorrow I'm going to draw another wave diagram. Tomorrow, though, I'm going to ask you what is the frequency for that wave. So tomorrow you're going to get 5 definitions. You're going to get the 5 parts, and then you're going to get a bonus question, which is what is the frequency of the wave that I drew for you. So that's why I need you to know how to get the frequency. All right? So here we go. We're going to do this the easy way, okay? So again, I'm going to count the number of crests. 1, 2, 3, 4. Okay? Now I'm going to go to the troughs. 1, 2, 3. Do they match up? When they don't match up, then here's what you know. When they don't match up, you know your answer is going to be 0.5. Okay, that's what you know it's going to be. It's going to be 0.5. All right? Now the question is, what goes in front of the point? Well, what was the smallest of the 2 numbers? 3. So 1, 2, 3, that's the smaller number, so I'm going to go 3. But because the 3 down here doesn't match the 4 up here, then it becomes 0.5 hertz. And that's your frequency. 3.5 hertz. Because again, how many times did the pattern repeat? It repeated 3.5 times. Once, twice, 3 times, and half of the other 4 times. So that's why it's 3.5. Okay? Does anybody have any questions about that? So we're good? That's all my lesson is. Okay, like I said, I knew I was only going to have 30-something minutes, or at least I'm suspecting, because they sent out a schedule, so I assume we're on the regular schedule. My feeling's about to be hurt if they go into a number schedule and we're going to be here for like another 15, 20 minutes. All right? Does anybody have any questions about this right here? So tomorrow, when I give you a wave, you can figure out the frequency. But remember, if I say the frequency, like let's say this right here. Let's make it simple. Kevin, this one's you. All you. Okay? What's the frequency?
2.
Okay? He says 2. Why is he still wrong? Like, why would he be wrong on my quiz tomorrow?
Because you didn't put the units behind it.
You didn't put the unit. 2 what?
Hertz.
2 hertz, right? So you got to make sure you put that hertz symbol there. Okay? Don't just say 2 because you know how to count. All right? You got to make sure you remember this is a measurement. So it's got to have a unit of measurement after it, okay? Any questions?
Nope.
All right, then. That concludes the recording of this video.